exponential graph and functions. For an exponential function, it needs to have a base and the exponent. The base needs to be bigger than 0 and unequal to 1, and the x is a real number, so it can be negative or positive. The exponential can be decreasing or increasing.
Okay, in this case, when the x is negative, you need to change it kind of like a fraction 1 over dx, and then that's going to equal a decrease on the exponential graph. And now the domain is always going to be negative infinite to positive infinite, and range is going to be from 0 to infinite, but it also like varies or changes depending on some variables.
Well, when you have a fraction on the function, you're going to go decreasing as well on the b minus x, and also the range bar you have some variability, because when you have a number out of the function of bx, and it depends, if it is positive the function go up, if it is negative the function go down.
Alright, now I'm going to talk about an example of an exponential equation. Well, the first need is an exponential equation, obviously. And just to show an example, these formulas, the formula appeared, the second formula, the third formula, which are used to realize situations are exponential functions. But right now we're going to use this formula. The f of x is equal to b elevated to x, b meaning the base. So in every formula, like for example this one, we only need to substitute the x with a number we want and put it instead. So we substitute the x with the number 1, we substitute this exponential x with the number 1, and we will get 2. So when x is equal to 1, y is equal to 2. So we use graphing here. And then we go on down. When x equals 2, 2 elevated to 2 is equal to 4. So when x is 2, what else? 4 to the 3, 2 to the 3 is equal to 8. And then when x is 3, what will be 8? And that's basically it.
Chernobyl was a catastrophe. It happened in 26 April in 1986. It was in Ukraine. In that time, communism was all around Europe, and the people of Chernobyl need energy. The nuclear reactor gave that energy that was needed. The nuclear reactor of Chernobyl was very important for the whole communism. There were 4 reactors. The newest was the 4th, and it had 3 years old. But first, to explain the catastrophe, I have to explain how a nuclear reactor works. It has turbine, pump of water, and uranium. The uranium functions with rods. With rods down, it makes less heat. With the rods up, it makes more heat. The pumps of water give water to the uranium, and uranium produces heat. This makes steam. The steam makes that the turbine work and produce energy. This was a catastrophe made by the young people and the human error. The young people was trying to make a test to know a simulation if what if electricity goes down. They cut the pumps of water and give an extra pump of water, but the people start giving a lot of water, and this makes that it does produce a lot of steam to the turbine. So people, the uranium, start giving a lot of uranium, and it produces a lot of heat and a lot of steam. The people of water realize that they give a lot of water, so they cut it and give it this. But the uranium is still a lot, and this makes to be really hot and explode. And well, that disaster, that explosion, killed 28 employees. Then firemen go and try to eliminate the fire, but the radiation was a lot that 31 of the firemen died. This also caused the radiation that people from nearby the nuclear reactor evacuate. The radiation was too much that it affects people of other countries. It even go far enough to USA.
This is the first chart of how the uranium temperature increased during the catastrophe of Chernobyl, which my partner Cesar explained. So basically what happened is as time went on, the temperature increased. There is no exact rate of how much the uranium increased over time, but this is an estimate. What first happens, or the first step, is that the uranium started as a solid object. Then as time went on, heat increased, it became liquid, and then it became vapor. So here is a chemical reaction which happened with the malfunction of the pumps, the air ventilation in the Chernobyl accident. So in here, the equation will be, the Earth equation will be where temperature is equal to the original temperature of the uranium times E elevated to the rate of increase of the heat, which isn't, we are capable of knowing, and times the time it took to increase the heat. So as time goes on, the heat increases continuously. And this formula is the result of an exponential growth as time goes on.
The first like situation can be the sales of smartphones from Apple from 2007 and 2015. Here's a graph that shows the number in millions of the smartphones that sell in each year, and the equation, it only grows exponentially. So it keeps growing continuously. So we use the equation third, and the total sales of smartphones equals 1.39 plus E, because it was the original number, and then E with the exponent of the rate of the increase plus the time, the years that it was sold the iPhone smartphones. Remember, this is an approximate equation with the rate and the original smartphone sold. It's an approximate. We don't have the rate, the actual rate, the exact rate. And this equation is total sales of smartphones equals the original plus E times E with the exponent of the rate, that it's an approximate, plus, times the time.
Here we have the iPhone sales comparison. We have a graph by year and by millions of the sales of the iPhones. First of all, for you to get the amount of sales that an iPhone got, you get the equation APER, and then you can see the initial is 11.63 times E elevated to the rate, which is not exact. We have an approximate of the rate, times the time of the year, times the year. If you want to multiply it by another year, you have to put 2, 3, depending on the initial price, initial million. And here we have the approximate of the rate, and if you multiply that, it will give you the amount of sales of an iPhone V1. But remember that this graph represents the versions of the iPhones sold, not the amount of total iPhones together. It's depending on the version you bought or they bought. And it also explains the exponential.
What is exponential growth? Exponential growth is the increasingly rapid rate in proportion to the growing total number or size. What this means? It means that it gets bigger and bigger and bigger through the time. And what is the function and graph that models and represent it? The function is PERT. This means the answer equals to the initial time or what you want to do, and E multiplied by E elevated to the rate and the time that you want. Then this is an example of a graphic that goes exponentially growth. Then what is exponential decay? This is the opposite thing of exponential growth, because also a graphic can go in decay. This means that it grows less and less and less. The main characteristics of the function of the graphics are time, rate, original or initial amount, and E, and also the final amount.
What are the implications of using nuclear energy, and do you consider nuclear energy to be clean energy? The implications of using nuclear energy is basically by undergoing through the process of fission and fusion of the atom. During these two processes, the atoms expel a lot of energy, and by this operation the energy is stored and for later use. And the question is that is nuclear energy clean energy? It could be clean energy talking about air and pollution because it does not pollute. But the thing is that after using this process of fusion and fission, the materials, the chemical wastes are too much and are too radioactive to be stored or just to be thrown away. So this is why these things have to be stored and for hundreds of years. So there's basically a never-ending cycle of waiting for 100 years until you can later produce more or to throw out more chemical and radioactive stuff that is produced by it.
Are you aware that there is a nuclear energy plant in Mexico? Where is it? Do you think it's safe? Do you agree with the fact that there is a nuclear energy plant here in the country? Yes, it's called Central Nuclear Laguna Verde, and it's located in Alto Lucero de los Ríos Barrios in the state of Veracruz in Mexico. We think it's safe because it has security systems in case of anything problem or boom develops. We can like shut it down in sections. There's various ways that we can stop a problem. And well, we do not agree with the fact that there is a nuclear energy. Yes and no, because we think it's great that we can make our own energy and it's somehow clean. But after Chernobyl, there has to be precautions to stop any possible outcome. So we have to study every bad development or any problem immediately and create security systems.
Could the Chernobyl 1986 nuclear disaster have been prevented? How? Once the explosion happened, was there any way to stop the radiation spread and its pollution? Do you think that the radioactive pollution generated by the disaster reached Mexico? What are the least 4 environmental consequences of the Chernobyl 1986 disaster? To the first question, the disaster could have been prevented by the constitution of better design, since the reactor design was unsafe and unstable, and having more security systems in case of a possible disaster. How? Well, I already answered that. Once the explosion happened, was there any way to stop the radiation spread and its pollution? The spread of the radiation could not be stopped because it becomes a toxic which only expanded more and more, invading other countries. Did it reach Mexico? We think that the percentage of toxic could have a Chernobyl disaster reached Mexico because it reached the United States and Mexico is really close to the USA. Since we're just in the border. The last question, what are at least 4 environmental consequences? The food health and resources become affected by the radioactivity. The animals and humans become mutations because of the radioactive materials. Humans acquire cancer and other diseases because of the radiation. The groundwater becomes undrinkable, so it's useless. What are the environmental consequences in a global scale of the nuclear disasters and use of nuclear weapons? As quoted from this link, nuclear weapons pose the single biggest threat to the Earth's environment. Scientists have warned. According to the research, tens of millions of people would die. Global temperatures will crash and most of the world will be unable to grow crops for more than 5 years after the conflict. The scientists said a sudden change to the Earth's ecosystem because a nuclear blast will be the worst than any of the effects predicted by global warming due to the greenhouse gases.
What do you think and feel about these consequences? What would be a solution proposal for this situation? We think that these consequences are really possible to take place in our time, with all the political conflicts and revolution in Syria and nuclear weapons. Iran could mean the end of the human race as we know it, and it will be really difficult to repair the damage done if we survive the first attacks. A solution can be a creation of a group that is focused on a peace treaty or the resolve of a nuclear disaster or any war or any problems with many nations. That way more people are involved in the security systems of the countries and can make a difference.
Okay, so how we felt like working this subject and this work. So we thought that it felt good to find like equations to real life stuff, like to apply the math that we learned in the theory classes and apply them in the real world. And the thing that I liked the most was the subject of the nuclear energy, nuclear fission, nuclear fusion. And nuclear disaster is a very creative subject and very interesting subject for me. And I like working in this, and I hope that we have another one.
Another thing that we feel about this project it is that we realize how nuclear reactors and industries of nuclear activity are so damaging, and they could cause a lot of things, damaging things not only in things like objects, also in people.
So you mind.
Ahí está Alexby.
Alexby.
¿Dónde estás?